Hello everyone, as you know I am Paul, your e-hobby guy. Today I'm looking at a very special tester module. You can buy this in a build-it-yourself kit if you'd like, but essentially it is labeled a transistor tester, but this does a lot more. And so it can be powered by just a regular 9-volt battery, or you can plug in a regular barrel connector here, anywhere from 5 to 12 volts to power it. It is based on the Atmel Atmega 328P, which is all the way in there. I did take it off. As you can see here, I have it off, and you can see the Atmega 328P microprocessor in there. The amazing thing about this is all of the things that it actually does test. And so I'm going to quickly review this by putting a whole bunch of different components. And what's amazing is that for an e-hobby guy like me and all of you, you can quickly put many components in here, especially if they're unidentified, and this will identify them. So let's jump right in here. First we're going to look at a regular resistor. Let me pop this battery in. Okay, so I have my resistor on here, and this is the test button. So I'm just going to press test, and you can see, let me try and get some good contrast here. That is not the greatest. 152.4. Any two of these three pins can be used. I could go into pins 1 and 2, or pins 2 and 3, or 1 and 3. And there you can see the contrast, 152.4 ohms. That was fast. Now I know we can tell with resistors by looking at the color coding, or just by using a multimeter, so these are not too difficult. I am going to throw a different resistor in here just to show you. And let me go into pins 1 and 2, and again press. It's testing. Tells me the battery voltage 218.9. that this is a 220 ohm resistor, so you can see how quickly. Now it's not coming out great here on the camera, but I can see it perfectly clearly on the screen. So let's throw something else at it just to see the versatility of this. So here I have what looks like a diode. Now it's kind of small, but there's absolutely no markings. They're all worn off. And so if we don't know what this is, we can pop it in here. Any two terminals. Press the button. It's telling me I'm going from pins 1 to 3, and that it's a diode. It has a capacitance of 9 picofarads and a forward voltage, bias voltage of 667 millivolts. Isn't that great? It tells me which one is the anode and which one's the cathode, going from pin 1 to 3. It draws the diode itself. So now I know exactly what I've got here. So let's throw something else. Alright, here I have a transistor. Let me pop the transistor in. Now once again, many times the transistors or any components can have their markings, and we don't know what it is. You pop it in here. There it is in pins 1, 2 and 3. It's testing. There it is. This is a Pnp transistor. It's using all pins 1, 2 and 3, collector, base and emitter. So it tells me which one is the collector, base and emitter. Isn't that great? That's amazing. So let's throw something else. So this one is a Pnp. Here's a different transistor. It's the ever popular 2N2222. Let's tighten down all three. Press the button. This you can clearly see is NPN. Pins 1, 2, and 3, emitter, base, and collector. Pin 1, 2, and 3. This is really great. So if you have something you don't know what it is, we'll keep going. It does so much. It's so impressive, all for a price of less than $13, free delivery. Here we go, an inductor. We have a through hole inductor. Let me put it in any two pins. Inductor's in. Press the button. There we go. It has an inductance of 0.04 millihenries. 0.04 millihenries. I don't have to go to my chart. If I've got this, I'm wondering what it is, I can pop it in and get an answer really quickly on what kind of an inductor it is. Let's keep going. Here I just have a regular non-polarized capacitor. Any two pins again. There it is. Press the button. It's using pins 1 and 2, and this is 898 picofarads. This is actually 0.001 microfarad, so it is 102 picofarads short of the 0.001 microfarad value, but that's perfectly fine because I can measure its exact capacitance. Let's go with a polarized capacitor. I think this might work. Let's see, this is 4700 microfarads. Let's see if I can get this in here without doing too much damage. There we go. Let's test this. It's taking a bit longer. I think it's probably charging it 4999 microfarads, so it is quite a bit off. It's 299 microfarads more than what it's labeled, but these all have they all have tolerances, and of course, because this is less than $13, it may not be the most accurate, but that's perfectly fine because it is less than $13. Let's keep going. Let's try something else. Let's pretend like we don't know what this is. I'll just pop this in here. Press the button. It's a Triac. So there's the gate on pin 1, and then there's the AC terminals on 2 and 3. Isn't that amazing? All of these different components in this very inexpensive tester. Let's keep going. I have a couple more to go, then we'll do a quick review. Let's see what we have here. Let's press. This is an N-channel MOSFET. Source, drain, and gate on pins 1, 2, and 3 respectively. N-channel MOSFET. It's exactly right. I'll do one more. Press the button. This, you might have guessed it, is a P-channel MOSFET. Pins 1, 2, and 3, source, drain, and gate. So that'll conclude what I'm going to test for today. It's really an amazing piece of equipment, and so let's wrap it up. Well, you've probably guessed that I am highly impressed with this tester that I got on eBay. I'll put a link below to the seller that I bought it from. You can buy them in build-it-yourself kits. It's a simple 16 by 2 LCD. Like I said earlier, there's the Atmega 328P microprocessor in there, fully programmed. I like it so much, I'm definitely going to keep it. Very handy. I'm probably just going to power it with a 9-volt plug-in transformer, besides worrying about the battery. If there's a couple of things that I had to say about it that were shortcomings, these wires are very flimsy. they're flimsily attached here. I definitely probably put in some strain relief or something. Wire tie them onto this hole, something like that. Also, you know, having to screw and unscrew, it would be nice if I could have a quick release, but for smaller components they do have to be this close to each other, and so there's maybe no easy way around that. I know that there are some terminal blocks that you can have spring-loaded, one at a time, spring-loaded terminals where you would just depress it, push a wire in, release, and it bites down. However, for components like you know, like a transistor, for 3-pin components, it may be difficult to press all 3 down, get it in, release. I'll think about that one a little longer. So once again, you know, probably a shortcoming, screwing, unscrewing. If these screws wear down, I could definitely just replace this with a 3-terminal block that I've got lying around. I'll probably power it with a 9-volt DC power, you know, with a barrel connector, and I probably I would like to actually mount this in some kind of a housing. Now this is, it seems to be a standard board, so I'll look for a housing. Probably have to detach that to mount it up, detach this to get it mounted on the surface of the housing, and get this detached and mounted onto a housing so that we can get, but I will need access to this. I would be afraid to detach this and mount, afraid for any readings that it may be taking and may be inducing some capacitance by extending the leads. Though its accuracy is not the greatest, it may have no effect at all. In fact, I could start taking some readings. So all in all, this is unbelievable. I highly recommend, if you're a beginner, for $13 it is very handy. So you can test lots and lots of components, especially if you're scavenging and you don't want to get out a magnifier, and you can pop things in here really quickly to see if you can get, you know, tell what exactly it is. So I just want to thank you again for taking the time to watch me. Follow me on social media. Remember to rate this video up and subscribe to my channel. Once again, thank you for watching.